Hey everybody, this is Larry. This is day 22 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. Oh, we got a hard one today. I just came back from my 5 miles, but I just was feeling tired. I think my legs are still like very tired from yesterday for doing squats and stuff like this. So like my heart rate's all over the place. I'm not feeling good right now. I just took a shower and here I am. Yeah, don't really have much to say for this one. So let's get started. Yeah, and we have a hard one, so maybe I need all the time. Today we have it is 10 o'clock here right now, so I have 2 hours before midnight. And the relevant is that I just have to do my Duolingo, otherwise I lose my streak. So anyway, 3501, maximize active section with trade 2. You're given a binary string S of length n, where 1 represents an active section, 0 represents an inactive section. You can perform at most one trade to maximize the number of active sections in S. In a trade, you convert a contiguous block of 1 such that surrounded by zeros to all zeros. So afterwards, convert a contiguous block of 0 that's surrounded by 1s to all 1s. So it's same as yesterday so far, right? Additionally, okay, so you're given queries instead, giving a substring. For each query, determine the maximum possible number of active sections in S after making the optimal trade on substring. The substring. Have I solved this before? I guess so. Return an answer where answer sub I is the result of queries of I. I think this one is not too bad, right? If we kind of, and okay, just to be clear, everything I'm going to say from this point builds off what we talked about yesterday already, right? Because yesterday we did part 1. There's some principles that I talked about. There's some greedy observations that I talked about. The code looks pretty simple, but you have to understand it, right? Because I don't want to go over it again. This is already a hard one. I have a good idea, but I'm very prone to making mistakes, is what I would say. I wouldn't be surprised I make some mistakes. So I want to jump right into it, right? So did everyone watch yesterday, right? I mean, I'll still like kind of talk about it a little bit, but you'll just probably get a lot more of it if you just either watch yesterday or already understood yesterday's, right? But overall, I mean, we didn't end up doing this because we only had one query, which is the entire array, if you will, right? But the idea being that, oh, I didn't put it on screen. The idea being that, you have a lot of zeros, 1, whatever, right? Even though my zeros and 1s look like each other. And as we said, the idea is that from yesterday's, this is kind of a little bit of a quick recap, is that we're trying to find the longest 2 adjacent group of zeros, right? Because the middle will flip to 0 and then back to 1, so no change. So then it just becomes these 2, and you could kind of do a really quick proof, because the other way that you may think about it is that, okay, you just take the longest group of zeros and then you subtract the smallest group of 1s. But by definition, it doesn't matter where the 1 is, because even if this is longer, you could just swap the next one, or you just kind of do it that way, right? In this case, you take this, and it doesn't matter that it's longer because you combine it with this, right? So okay, so that's the general, or that's the one where you take the entire array, right? So then the question for this particular problem seems to be that how do you do a query, right? So you just do this, right? I think it kind of, you could add numbers or whatever. I mean, I don't think there's. I think conceptually there isn't anything too complicated to understand, right? It's just a query. What I would do is maybe, for every index, I just put in some, I don't know, some pre-processed number, and when you go L and R, you have this, right? And then there's some edge case where, you have to kind of do the math. That you have this, but then, you don't want it to go like out of bounds or something. I have to figure out what happens when it's outside the query. Oh, okay, so it acts if there's ones outside a query, but you get the idea, right? So that you have to, if it's out of bounds, then you just do some math on the thing, right? Because the structure is going to be, there's this number, and then there's this number, and together, you have going this way, and then that's it really, because you can only go up. I mean, obviously depends on how you implement it, but the way that I would think about it is that if we do a binary search going this way, then it can only extend this way, and if it extends that way, then we just chop it off, right? We could do some math to chop it off. I don't think there's anything too tricky, right? Because even if this is 0, it doesn't matter, right? It just starts here. Oh, I guess it does matter, I lied, because you can imagine that, because we don't, I'm trying to think. There are two ways to store these, right? And I'm just trying to think which one makes more sense. One is that we just store the beginning of these zeros, right? Pretty straightforward to do. And then the other, of course, is just store the best answer starting at every index, which we can also do. I mean, I don't think there are any. That's the same color. I mean, I don't think there's anything too different, right? We just store here, and then each one will give you the long, the substring going forward. Yeah, I don't think it matters either way. I'm trying to think. Yeah, I don't think it matters either way, so we could just store it that way, I think. Right? We could play around. I mean, there are both ways to do it. I don't think it really matters. I mean, obviously, it means you implemented it a little bit differently. And of course, there is some complexity with space versus binary search. I don't know. I'm still thinking how I want to do it. I feel like binary search is less error prone for me. Because I'm not quite sure how to do it in a linear way. I mean, of course, you may just put it on a stack or something, right? So that when you keep going, pushing stuff on a stack, and then when you just pop all of these. Because technically, that's not a stack, that's a queue, right? And you just update all these queues when you go see this one or something like that. But I think binary search just seems more straightforward for me. And I think the only case, and I'm double checking by looking at this, so I'm not just keep on bringing it up, because I know how to do it, right, conceptually, but I'm just thinking through the edge cases that I might miss, and I don't think there are too difficult of edge cases. Could be wrong, and what I mean is that, like, if you have zeros, then you have to kind of do the one before, just so that you could chop off this piece, right, and then you kind of start here, and then so forth. Yeah, I mean, I think it's just a lot of being careful, but nothing too hard. Okay, so let's get started then, right? So for us, I will just do all the ones and zeros, and actually that's just like, group by is probably good enough, right? So you have G, I always say GT, I forget why. It's just a convention I use. I don't even think it's a reasonable convention, but right. That was equal to this, right? So then a start is equal to 0, or maybe left is equal to 0. So then right is equal to left plus L. Is that inclusive? So because if L is 1, then it's 0 plus 1, so it's not inclusive, right? So yeah, maybe we have like, no, I just got it away for now. We might use other data structure, but there's no update, no modification, right? So I think this should be good enough, right? So because then you can do append. We can say left is equal to right on the next one, because it's actually let's make it inclusive, right? So then left is going to be inclusive, and then it goes to L, right? I don't know. Or well, just L of these, and then it is just G for the number that we care, or it's either 0 or 1 is my point. Maybe I'll just convert to an int, because why not? Right, and then that's really the data structure that I need, right? Because everything else we could binary search on the index, right? So then now, I think it's just I mean, the tricky thing is that there are, the tricky thing is that there are a number of cases, and the ideal way to write this is to kind of like, I don't know that you can do this with this problem. I don't know if I can do it with this problem. We have the left kind of edge case and the right edge case, and ideally you make them independent so that they don't kind of link to each other, right? You just kind of do it. You do something on the left, you do something on the right, and you do some math. But I don't know that you can necessarily do it this way. So we might have to we have to kind of consider them. But there are two cases, right? Oh wait, no, I'm really wrong on this one, am I? I think I messed up. Because for some reason I'm just drawing it terribly. Because I forgot that we're trying to find. Oh man, I messed up. My bad. I have to think about it again. I don't know what I'm doing. Because I've been thinking about the edge cases so much that I just forgot about like the obvious case of like, if you have like a lot of these, and you have these, then maybe there's 2 0. Then you have to figure out the max that's inside, right? I was so worried about the outside edge case that I didn't think about this. And of course, the way you would do that is just by doing a max, right? So you could probably do just a segment tree or something. Do I want segment tree? Is that too heavy? Right now I'm just trying to think where I could do it with a binary index tree, and I don't know that you can because it's not really a prefix only. I mean, you could do it with like square root decomp, but that's not faster, right? I mean, it's not hard, just annoying. They really picked an annoying day. But okay, so yeah, I mean, this is probably neat anyway. We just basically have a segment tree. We basically update left to L or something like that, and that's probably fine. What we want is a segment tree that is point update, range query, right? Because we're querying over a range max, and that update is just we only update one at a time. I mean, we only update once, so it's static. So I'm trying to think. I mean, yeah. Do I want to implement segment tree from scratch? It's not that hard actually, but I don't want to do it. I'm gonna find my code. Hang on, friends. This is like one of the few things I have templates for. Maybe I need to be less lazy. I mean, I actually could. This is one of the things that I actually have gotten to a point where I do actually, if I need to do it like live, I could do it. But I'm just like really lazy, and I don't want to explain it, and it's going to be like a lot of dead air, and I'm just tired today. That's an excuse, reason. I don't know if you accept it, but that is, and this is actually the max one because that's my default one is max. Yeah, and luckily it's the easy one because there's up range query and point update, right? So what to do? We do have to change this to okay. So that is it? Of course, segment tree. N is N0. An update. I didn't change it. So is this the one that I always forget which one I use? Like this is one indexed, right? So yeah. So we update. What is it? 1 0. Yeah, right. So that's basically the segment tree. My apologies, I'm not going to go over segment tree today. There are a lot of videos out now, especially ones generated by AI, so you can definitely check those out. But yeah, but you can also think about this for now if you really want to just solve this one. Think about it as a black box where you have, like I said, I mean, the way that I wrote this is a little bit weird, but if you just, I said Google, but maybe even ChatGPT up a template, you'll find it. But yeah, you have a max over a range query, and you have update over a position or point or index, and there's a black box. Everything is logged in. Just trust and keep going, I suppose. Okay, so then now, what am I doing? Now, just queries, right? So query for left, right in queries. I am wondering where, I mean, I did say that we can do a square root decomposition, and this would make a square root decomposition, but I forgot the constraint. Constraint is 10 to the 5th, which makes square root decomp a little bit tricky, but yeah. That would be funny though, if we do a square root decomp, or what's it called, most algorithms more specifically. Maybe we still can, to be honest, but yeah. So okay, so then now what we do to it is that given a range, say this range, we then now get the one that overlaps outside on both sides, and then just get the stuff that's inside, right? Yeah, except for that, well, we have to do some math to kind of bring this index back in so that it doesn't kind of cover the one outside. This is so annoying. I would also say this is probably not on your interview. If this is on your interview, I don't know. I mean, your interview hates you anyway, so you probably wasn't going to do well, with all due respect. Okay, right? How do I want to write this, right? So left, let's just say we binary search for left first. Right? Array, left. We want it, so if it's on it, well, it doesn't matter if it's on it or not, but you have to look at the zeros and ones anyway, right? Do I need to care about the ones? I guess I do, because you might live entirely on it. Okay, fine. Right. Whatever, it really shouldn't matter for these two. Right, so then now we have this. That does make it easier, actually. Like, ironically, because, well, maybe. In the sense that when I was talking about the edge cases, yeah, I think this is okay. So then now this we binary search, so we find either 1 or 0. So we can actually check it, right? So if okay, so this is the case where let's find the part sticking out the left, right? So if array of our index, well, I guess we have to check that out. Our index is less than length of array, and so it's going to be this is the length and the group. So I want to say that if the group is a 1, then we go outside, right? Otherwise, then we just don't go outside, because then it's covered by max anyway, kind of. So okay, so if this is equal to 1, then now if this is equal to 1, what does that mean? That means that, oh, I'm not showing it, so I mean, I'm not writing that much anyway. But if this is equal to 1, that means that you, I'll just do an ASCII art instead. That means that we're like here, something like this, and we are searching for, say, here, or actually it could be here, but our binary search will find here. So then now we're just trying to figure out So that means that by definition, okay, so let's just say best is equal to 0 for now, and then we have an answer array. Right. So by definition, that means that if L index or if L index minus 1 is greater than 0, meaning you can go backwards, that means that it exists. Zeros exist and that we're cutting it off. So that means that best is equal to max. Okay, so that means that count, let's just say count is equal to 0, and count is equal to L index of no, because the query that you're looking for is left, so this point is left, right? So it is going to be the location. No, that's not the location. This is the location minus left is going to be this delta, right? And then now we want to, so that's this, and then if L index plus 1 to look for here, right? Then if L index plus 1 is less than length of array, then technically you want to add in the entire number, but only up to the right, right? Okay, so basically you want to go, this is what I was talking about when I was talking about edge cases and why I hate them, because I knew there would be a lot of these, but yeah. Okay, so that means that we haven't gone out of bounds. Then the right bound is going to be L index plus 1, array of this, 0 plus index plus 1, because that's the, so this is the index, this is the length, so that's going to be the right side. So we want the min of this or the right, minus, so this is going to be the right endpoint of the thing. So like, let's say here, right? So this, it's going to this minus the beginning. So it's going to be this minus, I want to say either this or this minus 1 or something, right? So I think this is right. I mean, either this or minus 1 of this is right. Okay, so that's what we should do here. And we're not even that. Anyway, best is equal to max best count. How did that fall over there? Right. I'll run it real quick just to make sure that I didn't do anything funky. Okay, right? So then now the other case is, now we're going to the right side, right? What I want from here actually. So the L index, we could probably update left even, right? So after this, oops, we can update left to array index, L index of 0, maybe. Basically, we're just updating the constraint to search from here. Though I don't think, even in this case, actually, I don't think we have to update this in this case, because I only worried about it going out of bounds, and it can never go out of bounds from the left side, right? And we already factored that in, so we should be okay. And what I mean by going, we don't have to factor about left side, is that I do want to do an inclusive range on the segment tree. But what you don't want to do is that, for example, we just naively do a segment tree on this range? Well, because let's just say they have extra zeros that go out. Well, if you store the number here, then you may get this number, right? So you have to kind of chop this one in, but you don't have to chop it in on the left, because if these are all zeros going out of bounds, then this is already not inside the range. So that's why there's some asymmetry there. And that's what I'm trying to think through to make sure that I'm not lying to you before. What did I click on? Oh man, my face is gone. My face. I don't even know what button that is. It's been a while. Oh man. I have too many things on this thing. Oh. It's there, but it's behind the screen for some reason. Oh, there we go. Oh no, I have to press the button. Okay. Technical difficulties. Okay, so that means that we have to shrink the right side, right? But first we want to do the right side. How do we want to do the right side? So let's look at this. Well, we do a search, and if the number is a 1, right? So okay, let's try it first. So our index is equal to bisect dot bisect. Oh, I never thought of pen best. Wait, did I delete that? Bisect left, away, right, to do whatever, doesn't really matter. Okay, so if, well, we just have to make sure that is in bound first. If it is, oh, I didn't do anything about if it's a 0. The thing is that if this is a 0, by the way, on the left side, that means that you have something like this, and that means that this will either be, there are two cases, right? One is that the answer that comes from this index will be entirely within your range, meaning it looks something like this, right? Like if you have something like this, I don't know, something like this, then now the number is entirely within your range, which means that your segment tree will be okay. Or it goes out of bounds like this, and the next part we will shrink it before the segment tree. So that's why we don't have to handle it if it's a 0, because we bind it, because that's what happens, right? Okay. I mean, I'm definitely, it's already a mess and giving me a headache, so wouldn't be surprised if I'm very wrong, right? So anyway, let's go to the end part. Okay, so if this is a 0, then what does this mean? This means that we have something like this is the boundary, we have 1, 1, 1, 0. So that means that we don't have to care about it, because the boundary is at 1 anyway. No, that's not true, is it? Because the thing is that what we're storing, no, am I storing this way? No, I'm storing this way. Yeah, okay. Yeah, so that should be okay, because the next 0, the reason why I got confused myself is that we actually, I messed up anyway. Oh my. I have to, this is very annoying to implement. But what I'm storing here is actually the, just the contiguous zeros, and not the contiguous zeros plus either the previous one or next one, but it's not containing the best. So the segment tree would not have the answer. We have to adjust for that. Oh my, I hate, this is just annoying. It's not even interesting for me. It's just annoying. I think that's why I hate it. And today I just don't have the patience because I'm so tired. Okay, we'll use this to shrink the bounds for now before we do the query anyway, right? So okay, so that means that how do we want to shrink it? And also, like, I have to, this should have been like if int of g is equal to 1. This doesn't even make sense otherwise. There are definitely a few things issue here. And then you want the previous one maybe. So then if length of array is greater than equals to 3, then L we added by -1 is the one that we just added, so -3 of 1, right? Because that's the delta. Yeah, so it's this L plus the previous one's L. Oh no, I cannot do it this way. Oh no, I'm updating the max. Okay, that's fine. The array is storing the thing. This is storing the thing, right? So then that means that now, okay. That means that now we're here. When we binary search, we get a 0. It's here. We go to the previous one. That's a 1. We go to the previous 0. That's a 0. And then we shrink it again. So okay, but what if it's a 0? Or it is if it's 0. What if it's a 1? Let me double check. If it is a 1, that means that we have something like this, and we go to the next one. Then now, oh no, that means that we have something like this, say, and this is a 1. So that means that we cut off at 0. So that means that for the 1, we go back 1, 2, and we move this one too. Right? I mean, we have to do the math for this segment, but then you want to chop it off here for the query, right? Okay. I might just like, maybe it's 2 if statements. I don't know. Maybe we could combine them, but my head is not big enough to remember. Okay, so if it's 0, we'll just do what we said, right? If it's 0, like this, then no, if it's 0, then the cut is actually here, right? Then now you have 0, so the L doesn't matter. We go back 1. Also, I used the wrong index. That is just bad. We go back 1. That's a 1. We go back another 1. Okay. Oh my god. So if our index minus, so this is a 0, so -1, -2, it's there must be a cleaner way, right? I'm like doing really dumb things. But I mean, dumb but correct, but still, I feel like I probably could, this could be cleaner, but what am I doing? Oh, well, this is the 0, R -2 is always in it, unless this goes out of bounds. Like if the bounds is this, then this could be out of bounds. This is why I hate it so much. Maybe I should have did the one where just keep track. Maybe not, maybe I shouldn't have done it with binary search. I guess that's the maybe that's the thing, is what I'm trying to say. I don't know. Okay, let's do this first, right? Let's shrink this. So okay, so you have two cases. You have this, and then you have the zero. You have the case where it's 0 and you go to 1. If it's already at a 1, then which one is more general? So we cut here, then we have this 1. We know that we want to, we go here, we do the, maybe they're both just different. I was trying to like see if you could maybe like shrink one down and then it does stuff, but I'm just complaining a lot, honestly. But I also just don't find this problem that interesting. Like I'm trying to think whether I could have done this a little bit differently, and is it too late to do it differently? Whatever, let's just go for it then, right? So if it's 0, then all index, right? And then now we moved it to here, right? Can I similarly move this here? No, because you have to take account this into this one. That's the issue, right? Okay, so fine, let's just finish this one first. Okay, so this one you don't have to, so then okay. So then if our index -1 is greater than equal to 0, then we go to the last one, right? My brain is not working for this today. We're here. But I mean, the problem isn't that I'm trying to do the math, because that math is easy. It's just that I'm trying to think like, okay, well, the left index has to come into play, and what's the best way to handle the left index? For example, the other left index could be just like here, right? And then now what? Now you have to do the math again, and then it's just like really not clean, right? And I'm just trying to think, is there an easier way to handle this? Because I feel like otherwise this could be one of those things with like 8 wrong answers. And at the end, like no one learns anything. I'm certainly not learning anything, but okay, I think what I need to do is just cut it off from here, right? Because that is, oops. And then just do this in a separate thing. I think that's what I needed to do. Because the point here is that this thing is now possible for a query, right? It's going to the left. So, okay. So then now in the 0 case, we go index -1 is here, or index always, and then index -1 is here, right? And then now, like we want to set maybe right is equal to array of all index -1 of 1 or something like that, right? No, because it's whatchamacallit? What am I doing? It sets the right to here, but not including this. So it's this -1, right? I think that's right, actually. And then you have an else here. It's very awkward looking though. So maybe I'll just do. And then this one is this one on top where, okay, so we're looking at a 1, -1, -2, -3, which is ridiculous, right? And then now best is equal to the query. How do I max? 1 0 1. And then what was the other one? Oh, left right. Well, that's just to the left right. But of course, we'll run it real quick. Okay, well, is that not the thing we put in array? Array, I messed up the array. Huh? Why do I append random crap to it? And the answer, okay. Someone somehow got one right. But okay. 0 length 1, okay. Okay, I mean, just want to double check. Okay, let's see if it's wrong in the way that we expect it to first. Right, so we have 0, 3. Oh, I have to count the number of, because best is just a delta. So we have to do count the number of ones in between, which I guess we can do with prefix sum or something, right? What's it called? Prefix. What do we say? Ones. Right, so that's number 1. So then it's just going to be this plus prefix ones of. I think technically it's by plus 1 minus prefix ones of left, but this is before the before we shrink it, so that's why it's a little bit weird. So maybe old right. Let's just do old left as well, even though I think technically it's the left doesn't change. Maybe. Now it's well. 2. Why? No ones between. Oh, because it's not. Why can you? I don't. I mean, my thing would have been that you could just do this to 0, 1, but you have to convert a 1 to zeros first. So this is definitely an edge case. There's so many dumb cases. I don't care enough about this. I'm very demoralized. I mean, I'm just tired, and it's just not that interesting of a problem, you know? Like, it's not like I'm having fun solving this. It's just me knowing from the get-go that there are a lot of silly edge cases. And then, you know... and I'm not even getting them right. I mean, this one, I think it's... Okay, we have to check. Okay, maybe we just have to check whether there are... So if they're all ones... What does that mean? Of course. So if they're all ones... then you cannot do it, right? Is that the only thing? But this one doesn't have all ones. How do you check whether you can flip? If there's if only there are zeros on. Wow. Why is this so annoying? 0, 3. So why is this getting wrong now? So, okay. Let's actually look at this then. Let's work out some stuff. I don't know anymore. I'm so tired. 0, 3 is the entire array. Yeah, 4. Why is it 4? Well, because you come with this to 0 and you come with 1, right? Okay. What do I write? How? Okay, first of all, how do you check whether you can flip them to 1? Because if you can, then you just cannot do it. So you need 2 groups of zeros. Is that the answer? I mean, my question is like, am I missing something like crazy? Like, why is this so hard? Like, not even hard in an interesting way, just like annoying. Okay, let me. Like, I don't want to do more binary search to find out if there are 2 groups of zeros inside the range. That's why I'm like trying to think. Because that is just ridiculous. Hmm. I hate everything about this. I'm just trying to think now. I'm just trying to rethink what's the best way to kind of like simplify this. Do I not do the right data structure? I guess we have to do this count 2 zeros thing. Why does Leetcode hate people? Why do I have to save that one to save? F you. Maybe I just don't know how to do it. Maybe I am dumb. At least the examples are good, I guess. Just trying to see if I missed something. There are 5 hints. I don't think they're gonna tell me anything I don't know. It's just, can I do better? Okay. Maybe this is too lazy. Why is this wrong though? Oops. I mean, this is wrong, so that's fine. Why is this wrong? Why is... It should give me... Oh, I messed up, didn't I? I messed up, because this update is actually not on left. It should be on... this. Okay. Oh, this one I don't know, but it doesn't make sense because my because I was updating here the YU3, which is why it's wrong in the way that I didn't expect. But now it's 03. This is 1 is still also not the way that I expect, I guess. Oh, wait, why is this 1? I meant 0. Wow. Okay, well, that explained it. But I think I got this one right just by luck, though. I don't think this is right. Zero 2. So okay, so this returns max out of here, which is definitely not right? But because we have to trim the right. What is the left right on this one? It's definitely wrong. So we have 0 0, but it's giving 4 because it contains this. So it was this. The right side, we binary search for right, which is 2, 0 1 2. It returns this one because it's on is 0. What do? We go we go here. This is the right side, -1. That's not right. Well, if it's 0. Oh wait, no. Yeah, no, it's okay. So it went from 2 to 0. Why is this 1? Oh wait, why is this 1? Wow, is that just the length? I am just really bad at this, even though I didn't even finish it. We're not even close enough to being good enough to do. Okay, so this is what I wanted, and then maybe we could write something like here, where actually I already did. I guess that is a good default. And then I don't know why this is -1 because that's funny. Oh no, that's not -1. It just gives me 1, which is I wouldn't say expected, but because we didn't do the thing where we had to do the trim, right? So okay, so it's here. So what's the case again? I had the other case. So okay, so this is if it is 0, you have 1 2, right? So then now you have r index minus 2 of 0. If this is greater than equal to left, then maybe we have to do it from this to the old right first. Okay, so then now it is going to be current right is equal to r index minus 2 of 0, so that's the thing, plus, now all we need to care about is, so we're in this case where we see the 0. So that means that we actually really don't care about it, right? Because yeah, we actually don't really care about it because this just by definition goes out of bounds. This one would include this one, so I think we're happy. Yeah. And then for the other case though, okay, so then now we have here, but then now this extends to whatever the length is. So you have this. Do we contain the max? No, I mean it's going to be this plus okay, so it's okay, so you're at this 1, so array of r index minus 1 of, so it's going to be the old right, so you have the min of either the old right or the this plus L, and that is going to be on the, yeah, that is this part. Well, no, it's right minus this. L doesn't matter. No, if you're here, then okay, so you're here, you find this here, that's an index minus 1 is this number, so then this is the number, and then it's either the min of here, and then that's it, right? Because right by definition, because the fact that we search for them will be bigger than this number, so that's the delta plus so this is the thing, right? What is this? Oh yeah, this is just plus the previous thing, assuming that this is to the left. Otherwise, then now we have the other case where it goes like do, and now we have something like this, then what? Then now else best is equal to max best. Well, if this is the case, then it is just, you only have one set of ones, so you're just going to be all ones from there, right? So it's just going to be right minus left. I mean, it's not inclusive, it's not everything yet, but I just want to run it real quick just to see, because I wanted to see directionally consistent, right? And here it's not, because this is smaller and this is bigger. Okay, so 1, 3, again, we don't know how to not flip this. Well, I don't know anyway. But this is also 1 is, well, I guess 1 is fine. It's kind of expected because this is the range, but not really, right? Because you have 0, 1, but that's afterwards, right? Just double checking. Yep, 0, 2 to 0, -1. It should go to here, but obviously it doesn't. But oh, because does it go here? Because it goes out of bounds. So 0, 2. No, it doesn't go out of bounds actually. It just goes exactly here. That's the trouble, I guess. It's the trouble that because when we do binary search, it goes exactly there, so it doesn't go to the next one if it's. Maybe we could make it a bisect, right? So I'm not explaining much anymore because I don't know anymore. My apologies, friends. Alright, so R next to Y. So the 0, 2 does not go there. Well, because it goes out of bounds, right? Which is fine. We probably could use a sentinel, but I don't want to count it. It's just so confusing. We could treat it as 1 because it's out of bounds, and this thing maybe. Okay, I mean, the 0, -1 thing makes sense, but it should also just do it. Island thing, we'll have to think about it, I suppose. So 0, 2 is here. Why is it only giving me 1 and the other one 2? Because this is true. Because it's greater than equal to left. Then as a result, alright. We're 1 on 1 3, but I think that's because I still haven't done the 0, 1 case yet. Let's audit the other ones if that's kind of right. 0, 4, 0, 1, 2, 3, 4. I mean, we knew that these kind of problems would be wrong, so that's fine. But the other two, maybe not so fine, right? Because you have 1, 2, 3, 4, 5. I actually 1, 2, 3, 4, 5. I actually do expect this one to be right, so that's actually not great. Oh, wait, did I miscount? 1, 2, 3, 4, 5. How do you expect 6? Am I missing something? 1, 2, 3, 4, 5, right? So how is this 6? That'd be funny if I just like misread it the entire time. I'm confused though. Actually, this is one example, so let's take a look. 1, 5. 1, 2, 3, 4, 5. Wait, I misunderstood something? Oh, it's max over all of them, not just the last, not just the chunk. So, okay, so why do I need the prefix sums? Okay. I mean, that's an easy fix, right? But why do I need the prefix sum then? I call it once. I was trying to understand it. I was so confused. Okay. Alright. So this is expected, I think. 6. Right? Oh no. 1, 2, 3, 4, 5. So that's 4 plus 2 is 6. Okay, that's fine maybe. 0, 6. 0, 1, 2, 3, 4, 5, 6. Do this. We get 5. Let's put it out. What's it? 0, 6. So this we get 3, which is not right. 3 plus 2, I guess, but it should be okay. Why do we get 3? So if we do a search for 6, we have 0, 1, 2, 3. Even though we do bisect right, so this would actually go off the screen, right? So we go here. Let's see if it prints. Okay, it prints. Good. Nope, it doesn't print. Not so good. Why? Did I do this right? I guess so. 5, 2. We search for 6. We're gonna go out of bounds. Right? So why is this not? Oh, so then it's definitely here, right? So why is this not printing? Oh no, I'm looking at the wrong thing, that's why. Okay, I'm just looking at 6 and it is printing 4. Okay, it's 4. 4 minus 3 is greater than 0. So it goes to this branch of this 4, 3, 2, 1. So here, right? So the right, it's going to be 6 minus this thing minus. Okay, so this is the left one. So it is going to be this minus. Okay, so what it is saying is that if we had something like here, so it is off the screen, 1, 2, 3, so it looking at this, the right side is going to be here, it is subtract by all minus 1, which is here, so this 0, that's 2. Plus, oh, this isn't right. This is the, what is this? That's the left. So if this is greater than left, then we just take the length, right? All right, so let's see that we got that one right. Oh man, still no good. Just so not interested in this problem. Okay, so it's 4. Sounds useless. Why is this not right though? Is it here? Oh, because this wants to be this. I don't know if that messes other things up. I still didn't even do the count 0 thing yet. I mean, there's no way it's infinitely loop. We don't have any loops. So it's just Leetcode being slow. Is this right? Length. This is the right minus this plus 1. This is the left index. Okay, so we got this right. We got everything right except for the case where we cannot do any. Right, so that's fine. Maybe. Sorry. 1 3 2 3. Okay, so how do we do this? If there are no ones in between, which we already have the prefix sum for, so I guess that's easy. And we're expecting like 5 wrong answers, hopefully not, but you know, it is what it is. So if prefix 1, so 5 plus 1 minus just ones, right? Because just no delta. Alright, so that's good if it doesn't exist, but we have contain 1. How do I do it? You need 2 group of zeros. I can keep track of the indexes, I guess. Where's my beginning of code? Yeah, okay, fine. So if these are the zeros, right? So previous is equal to -1, count is equal to 0. So if x is equal to 0 and x is not equal to previous, then c index dot append count increment by 1, and then previous always is equal to x, and that's it. Maybe. Let's see, let's print out z index. That would be nothing, Larry. How are you doing? That's still nothing, which is not great. X is int. Why did I not just int it once? I'm too tired to do all these things. But okay, so 0 and 1, which is not right. Right? Oh, I mean, what I want is actually always doing it. Yeah, okay. So then now, yeah, because then now you have this thing where it gives you the prefix of how many zero groups there are. Is that true? 0, 2, 0, 2. Huh. Oh, okay, I think that's right, maybe. If the index of right plus 1 minus the index of left is less than equal to 1, and also just do nothing. I don't think this is 100% right, but you know what? Listen, you've been here for an hour. If you're still here an hour, let me know in the comments. But if you have been here for an hour, then I am going to YOLO, because please, no way. But yeah, and I didn't even go that far. Okay. 2, 4, 0, 1, 2, 3, 0, 1, 2, 3, 4. I put 2. Why is this? Is this one of these? Like, did I get this? So it just skipped all of them, right? 2, 4. Why? I thought it was something like this, but okay. So 0, 1, 2, 3, 4. So 2 minus. Wait, what? 2 minus 1 is less than or equal to 1. Okay, so there are 2 groups of 1. Am I doing this wrong? Maybe I'm doing this wrong. I'm just being lazy. That doesn't even make sense. Because, well, I mean, it's that I don't get the beginning of it. That's why it's less than 1. But how do I solve this? Sorry, something was not gonna lie. Real life, someone text messaged me. Now I can find the window. But okay, so we just have to count the number of things. But I am just being lazy. I mean, maybe just 2 binary search, but I'm just being lazy. And I was trying to do like some funky prefix something, and I've already lost my mind. All right. Okay. So it's not the start of 2 of them. That's why. It's just that if I think if it's just not the same, that means that the 2 groups exist. I think that's already they're the same, then they're in the same group, right? But otherwise, maybe that's okay. I don't know, honestly. Oh, I was hoping, but why? 1 and 3. Oh, because this 1 is the ID is not right, is it? There must be a smart way, but I'm just like being really dumb right now. I guess I could just do binary. So I think I don't know. Okay, and then now we just do a binary search on the Z index. I just wanted real quick just to see my C index is correct. 02, alright. It's so error prone! That's why I didn't want to do it this way. Okay, so then now, bisect left, with the C index left, so you have L0, 0 to this, R0, 0 to, maybe it's not so bad. Where's it left? Maybe it's a bisect right actually. If LZ, no, what? Oh, I had it here. I was looking for it. I'm losing my mind. Listen. Listen. Okay. So still getting a 1 for this one because it's giving. Oh, what's this? So 2, 4 gives. Why is 2? Oh, because the 4 is not a. Do I want bisect left or bisect right? No, there's one group, right? So it's one group. No, 1, 4. Am I making the same mistake again? I almost certainly am. Because there are 2 of these, right? So, okay. So, okay, this is bisect left, and this is actually, I want it the other way, where if I think this is what I want, maybe. Nope! Well, consistently wrong is not that bad. Why though? Okay, so we have. I'm just not thinking. I'm just trying to like hack it, but my brain is not working today. Okay, so 1, 4, you have 2, but you don't know that. I see, because we don't know that the 2 belongs to the 1, right? I'm trying to think like, should I use connected components and like union find? But Alright. I just don't know how to do this apparently. Okay, so if is it called S? If S of left is equal to 0, then we just get the previous one. Maybe that's good. Still not unlocking it apparently. Well, we'll see. And and it's not the first one. So n z index about z is not equal to left. Why is this wrong? 0, 2. This is index C. Yeah, so this is index 0. This is index 1 for the first one. What am I doing wrong? Is it just this? No, I'm just trying anything. I don't know. How am I not knowing this? Today, my brain has failed me. Okay, so 0 and 1, right? So you go to the next one. No, bisect left will go to the next one, right? So what does this mean? This doesn't mean anything. What am I doing? So this goes to the next one. Oh, I see. We'll just have to check the length. Man, I'm just keep on adding random stuff to it. I mean, this is at this point I'm just flabbergasted. So let's go C length. Just tired. I think I should. I don't know. Okay, so then now 0 to 1, right? So okay, so we search for this. Is this the next one? If Alex minus 1 is 0 and C index of Lx or left is in between this and this, and we just go to the previous one. Of course, I've gone so bad I forgot Pythonic syntax. Why? That's not true, is it? Why is this 2? Maybe it's true actually. Okay, so this is index 0. This is 0 and this is 1, and then now maybe I could do this. Now it's doing the right ID. Why? Oh, I mean, if this is equal to, did I do this wrong the entire time? Okay. I think I'm making some progress, but I've failed the other way. 1, 3 is wrong. 1, 3 is this thing. So we do a binary search. We here. Well, the previous one is not, right? Oh, whoops, this is, no, this is if this minus 1 plus L. That's why I was, that's why I did this, but, and this is this minus 1, so actually I guess this is, right? Oh. Was it 1, 3, 1, 3? 1, 2. I mean, I don't know what to do with ones. Right. But also LZ should be the same then, right? Why is it not the same? Oh, I see. It's not the same because even though this is mapping to here correctly, I'm mapping off with the RZ. Because RZ needs the same thing, I think. To map it to the correct beginning. Oh, I hate you. Why am I don't know how to do this? Maybe I just need to Alright, reset. Apparently I don't know how to do any of this. I'm just following the same thing. Alright, does that have two different indexes? I don't know. What I don't even know anymore. Okay. Because one of them could be one in a corner. Alright, well. Okay, so we cannot remove the ones in the corner anyway. So maybe we'll do it that way. Alright, so if okay, so I'm just gonna iterate it. I think I tried to be too clever and I am just confused. Oh, I don't have the thing anymore. I kind of removed it because I had the indexing number thingy. I'm just lost today. I really was prepared for very quick doing this and then go to bed, but instead, it's been way too long. And I think I'm just stuck on this part. How do I not know how to do this? Two groups of zeros within a region. I guess I could put everything in segment trees. So at ID, right? ID of the zeros. If it's a 1, then we just go to the next one, right? Alright, fine. I guess I kind of did it before. No, but then you have ones anyway, so then that's the issue. Why am I done? Why am I done? Alright, if you're expecting to learn from this video, my apologies. I don't know anymore. Why? What is this? Again, why is this wrong again? This is wrong because I don't handle ones because it's searching this one and then just okay 0 and then you have this. Is it just because I have this? That would be funny. Okay, well that looks a lot more correct at least. Okay, so 0, 4, 0, 1, 2, 3, 4. Okay, this is the case that I do worry about. A binary searched into here. And here, this is not that. So, but that's what it is a 1. I don't know how to handle the 1s. Wow. So the left side, we handle the 1s kind of correctly by going to the left. And then here, okay, so maybe the first group of zeros, right? So it's going to be if s of right is equal to a 1, then we actually want to go to the previous group, right? What is this anyway? If this is a 0, oh yeah, okay. Well, if this is a 1, we also go to the previous group. So we get an else. All right, listen, I have no confidence, but I guess I'm just been lazy about case analysis. But still, this is probably wrong. But I am just going to YOLO it and then see what they give us. Okay, still not even that close. Okay, 0, 4, 0, 1, 2, 3, 4. Right, 0, 1, 2, 3, 4. So this is a 1. 0, 1, 2, 3, 4. I mean, okay. I mean, this is a different wrong answer though, because, well, the answer cannot be 6. So that means we didn't skip this, which is, so that part is, I don't know if it's right, but it's more right than before. And then now 0, 4, meaning that there are 3 1s, and somehow we have 3 in the answer, which is just like really wrong. It's probably here. Right minus left is going to be 5. That's probably not right. Let's see, is it here? Did I put it in? No, I put it in. Alright, that here is not very useful. I've been too lazy. I can't even find the code. What's this UI? Oh, there it is. What's it called? Left, right? Right, 0, 4 is definitely wrong. Okay. So you have to right is a 4, 0, 1, 2, 3, 4. So right. Oh, huh. It doesn't check that it is a 0 or not. Oh, because it goes out of bounds. Out of bounds, I think I just assume that it would be 0. That's why. Okay. I didn't actually check for this case because there are a billion of these cases. Because I check with the 0 ending, but I didn't check for the 1 ending. So if it's a 1, then what? Then okay. So if s of the last element is equal to 1, then what do? Then all index just subtract by 1, I guess. And then I think it's just right, maybe. Let's try again. Nope. Now it's just even more wrong. Yeah, because the odd index can go out of bounds, which is really awkward. That's probably why. But okay, so if it's a 1, then we just want to not care it, right? Why do we care? Oh, because the right, we have to update the right. Because we're no longer, okay. So maybe it is more that to that, and also right is equal to okay, so that means that we want to skip to 0. I can't think. Okay, so it's out of bounds. It goes 1, 2, 3, right? So then now here we go 1, 2, 3, 4 instead, right? So why can't I just do this? Because the right is not updated, so then it just adds in these 3 instead or something like that. Okay. Oh, actually, it adds in the last 2 because I guess that's what it assumes. Actually, I guess I could write actually the type is going to be a 1, then and on index my and then this is this -1 maybe. Okay, because yeah. I don't know why I just forgot the -1 because that is clearly the starting of the wrong index. Again, am I confident about this? Not at all. Let Larry sleep, please. It's too long. Larry's wrong. 2, 3, 4, 5, 0, 2. 0, 2 is this is the one that we should have gone, right? What? And this is the same thing though, right? Like this is the same as the other ones, and it just takes so long to run for some reason. Left, right, 4, 2 is probably wrong. Oh, I see, because we moved the left past it. That's why. I was looking at the wrong one actually. Well, no. What? Well, I think this is just it goes to here. So it's not doing anything, but it's definitely not great. But the 0, 2 is the wrong one. I have no idea where this 4, 2 comes from. I thought it was just 4, 4 in a weird way, but okay, so as you can see, actually this is unrelated to our wrong answer. Well, wrong answer is somewhere else. Our princess is in another castle. That's actually crazy. I'm just double checking. Yeah, wow, because 0, 2 is the incorrect one. So actually it should be here somewhere. Maybe. Well, here anyway. Alright, so we see that it's here. Last one is, oh, it is a 0. And on so then right is equal to this thing. But then we do not update it. That's maybe why. Because we don't do a best check. Why? Because, was it 0, 2? R minus 2 is equal to greater than 0. I mean, I did this case analysis, but I guess I did it wrong. So I have to do it again because I forgot it already. So right is equal to this. The idea being that if this is 0, then, but this is wrong though, right? Oh, no, it's now bisect. But why is all index? Because for 2, this is 2. And 0, 1, 2, infinity, infinity. This should be left, right. Alright, let's just print out our index. Let's not guess. Okay, so 3, so 0, 1, 2, 3, 3. Okay, 0, 1, 2, 3. Okay. Is that what I expect? Yeah, I guess so. But that's because I think I changed this to bisect right, but then I don't know why I updated stuff. I think something is a little bit off. It doesn't feel right. But yeah, but yeah, so then it does the 1. So then now this is a 1. So it goes here. And then it goes 3, so it goes 1, 2, 3. So we have this. It is equal to left, so you have this thing, which is giving you. Let's see. Let me double check. That it is over here. So okay, so it is going over here. So what's the number? So right, what is right? Right is odd. Oh, because no, it assumes it should be assuming that this is a 1. So 1 minus array of index minus 1, which is this one. If anything, it should be overcounting, not undercounting. Why am I undercounting? So it's all index again. 3, so it's 3, so 2. So it's going to be 2 minus 2. So this is 0 plus 1. I see. So that. Wait, 2 minus 2. Oh, this passage is not right because we forgot to add it to 1s. I mean, it's wrong anyway still, but this is just not right, right? Because it's just missed a factor. Okay, well, I'm not gonna lie, I'm very relieved that it's still past all the other ones. I mean, this one it failed, but that's okay because, you know. Okay, so this is 0 plus 1 plus 1 is. Oh, this doesn't even make sense because this is just the index. This isn't even the. But why would we? So this is the number of 1s, which is not even right, but a number of zeros. So it's a 1. We know that this is a 1. Why did I do it this way? What does this mean? So it's a 1. So then why is it not just... I don't know. I mean, I wrote this when I was not... Okay. That's actually even worse, but... Is that not the thing? No, it is L. Oh, there's still a right minus thing here. Wait, is that the place I'm... Nope. Also, this should be plus 1s, I think. Oh, no, we do best plus 1s. Okay, so we don't need to do the plus 1s here. Okay. So much code I forgot, but this looks more right. Okay, and it is more right. Maybe. I don't know. I mean, it's right for one more example. I have given all hope. All hope has been forsaken. Just want to go home. Like the Odyssey. Anyone watch that movie, The Odyssey? I'm Odysseus, apparently. Oh, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the answer would be... I guess this is 10, and then it's just my... So the 3... Okay, let's print it again. I guess it's here again. It's either here or here. Oops. Okay, so this is not the wrong one. So maybe it's here though. I think the right minus left thing. Oh yeah, this is not right. I think. This doesn't make any sense though, because it assumes that this is 1. But okay, well, this is not where the issue is though. 390123 4 5 6 7 8 9. Okay, just want to make sure. So this is on this branch, right? Let's double check. How can no, it's not. Why not? How not? Oh, 9 is out of bounds. I don't know what's out of bounds and what's not anymore. I need to do it +1 somewhere, but it's too late. That's what I should have done. Why am I doing all these things, but I forgot to do a +1 when I search? I think that's why. Something's missing a +1. The right bound is missing a +1, I think. Okay, so you have this. The 9 lengths. 0, 1, 3, 4, 5, 6, 7, 8, 9. So the 9 goes out of bounds, so it's here somewhere. This is a 1. You cut back, and then now we because it's doing well. No, yeah, this part, right? Okay. I mean, that looks wrong anyway, so I'm not surprised. So that's what wanted to see that this is yeah, because we probably moved right here. Yeah, I don't know why I did it this way. If this is left, I also don't know why. Well, okay, this makes sense, I guess, because it gets chopped off, maybe. If it's a 0, because if it's a 1, then we move back. So these are all zeros, right? So zeros. I just assume that if this is not left, then okay. So you start at 0, 1, 2, 3. But that is definitely greater than left, right? Oh no, it's because 3 is here. So then this, I don't know why this. I think I rewrote this too because this doesn't make sense either. What it should be is maybe something like So you have this. On the right side, and on the left side you get chopped off. That's why. You could also just do this minus just the number of ones inside, right? Maybe I have a prefix ones that I don't know I used, but we can use it now. Alright, well I fixed this, but I got this wrong. That's a regression. 2, 4, 0, 1, 2, 3, 4. Why? Why is this 3? Because right minus left, what is right? Oh, it's right minus left plus 1. It depends on. Okay, so this is the right side, so that's why. So this should be right. This should be this plus 1. That means the other one is wrong, so I don't know. Oh, it's not. Huh. I'm sure this is wrong, by the way, but I'm just gonna wait for them to give me an. It's fine. I accept it. I'm gonna get like 20 wrong answers. I try so much to avoid it. I failed to avoid it, and now we are going to battle it out. You know, this problem is no longer about the brains. This problem is about the heart, and we'll see. We'll see if we have enough heart today. It is what it is. And clearly, I did not start with it, but you know, some days you may not start with heart, but you hope you could end with heart, and that's all you can hope for. Oh, not there though. 0, 1, 2, 3, 4, 5, 6, 7. It just seems like a normal case. I think I just messed up, to be honest, in my right minus left thing. Like this should be at least like this. I don't know. I don't get it. But because it should be inclusive at least. It just doesn't get caught, I guess. But until later when I have to debug it again. Because I think I just kind of messed up my indexing for a lot of these, and now it's like a little bit late to change. Or I don't know how to do it. But all right, so what are we doing? All right, let's see if we're here. Alright, so we're getting one for 0, 7, right? Okay. So, okay. It makes sense that we made it this far. So 0 is probably fine. 7 is also probably fine, so it should be here, right? Okay, and it should be here. Nope. Huh. Maybe I... Isn't the last thing 0? Can we count again? 0, 1, 2, 3, 4, 5, 6, 7. Oh, because it's binary search. Did it up to the 1. So then it's here. And then it just goes to 1, 2, 3, 4, 5, 6, 7. Goes 1, 2, 3, which is here, right? So it tries to do this, except for the right is chopped, so it should be here if it's correct, hopefully. It is. So then 0, 7. So this chunk should be well, 7 only goes up 0, 1, 2, 4, 5, 6, 7, so it should be 3. Oh, it's giving me I did the full length. I guess I did add this. I changed this. Right. No, maybe I did. Actually, no, I did change this to this. So I don't know. I guess maybe there was some logic in past that. Okay, so this part is definitely true. And now we have to do right minus something like this, right? Yet again, force hope, but the heart wants it. We still have like this thing that I'm 100% sure is wrong, but I'm just waiting for a case, because at this point, look, we already got enough wrong answers. It's not going to hurt us anymore. Oh wait, how do we move a case? Because we just okay. See, I mean, I knew that this was wrong, right? But maybe we could just use this. I don't know if I could copy paste quite this, but I think the logic is about there though. No, just think about it. What are you doing? Alright, so that means that it is our bounds on the left. It's our bounds on the left and on the right. Right? No, the right is just a 1. What is this again? Oh, let's just look at this case. And this is 3, 5, 0, 1, 2, 3, 4, 5, right? So then it's, oh, because it's bisecting infinity, so it finds the 1. So then now it goes to 0, 1, 2, 3. This is chopped off. It's the same logic that I had here, I think. Except for that one is when it ends at a 1, so, or ends at a 0, because we did this thing. So I don't think this is quite right. What we want is actually just this, really. But with the left side is going to be this minus something minus left. No, it's left minus the beginning. Maybe I'm off by 1, actually. No, maybe it's not, actually. Alright. Once again, hope springs eternal, as they say. I have hope. I have dreams. Well, I would have dreams if I were able to go to sleep and go to bed, but maybe not today. Alright, friends, listen. If you watched this far, or if you skipped ahead this far, you'll know that this took like 2 hours. So, my apologies if I can't explain it. I mean, I think all the explanation was in the first like 10 minutes, and it's annoying to solve, as you saw correctly anyway. So I don't know. I don't really have anything to add. I apologize. Hope you find a good video to watch to learn this from, and then you can teach me later. Actually, let me take a look at the hints, because I think the first time I did it, there was no hints because I did during the contest. But alright, split consecutive 0 in a segment, and you. Oh. I mean, I kind of tried to do that. I did it with the zeros, but I didn't do it with ones. But that makes sense. That I was trying to do something like that. That would make it so much not dumb. Because that's how you do this part that took me like forever to write. Alright, fine. And this should be maximum of for where I is a 1 segment. Alright, that actually may be a little bit better than the way I represented it. Was yes. Yes. Yeah, you have to handle it. I don't know. There probably is a smart way to do it. I'm not doing the smart way today. I did it the dumb way, but you know, how many submissions I even have? I have 6 wrong answers, and last time I had even more wrong answers. So, you know, that's an improvement, I guess. That's all I have for this one. Let me know what you think. Apologies, gang. Thanks for watching. Stay good, stay healthy, take good mental health. I need some good mental health. I'll see y'all later and take care. Bye-bye.